All right. We'll just cut all these off and go to sleep. Okay, so today we're kind of talking about the law of cosines. We talked about in section 9.1 the 5 different cases that can arise when you know when you have triangles that are not right triangles. So we talked about angle, angle, side, angle, angle. Those are the 2 easiest ones. Anytime you know 2 angles, it's typically pretty easy. Side, angle, those are the worst. Those are the ones you have to look out for that second solution. And then side, angle, side, and side is what we're going to be covering today. So side, angle, side is where you know 2 sides and the included angle. So for example, right here, you have these 2 sides and we know the angle between them. And then side is where you know all 3 sides. The good thing about these problems, even though they are a little bit more difficult than the law of sines problems, is that you only ever have to use the law of cosines one time. After you use the law of cosines one time, you can use law of sines after that, if you prefer. You can use law of cosines to solve the whole triangle, but it's a little bit easier to use law of sines once you use that initial law of cosines for the first time. All right, so here's the law of cosines. It has 3 versions. The version that you're going to use depends on what angle that you know. So in the first version of this formula, you know the angle A. In the second version of the formula, you know the angle B. Third version of the formula is where you know the angle C. All right, so you have A squared equals B squared plus C squared minus 2BC times cosine of A. So it's sort of like an adjustment to the Pythagorean theorem. So this like term at the end sort of is that adjustment that we have to do to account for the fact that this isn't a right triangle. So you can see there's like a pattern. If you have B squared C squared here, then it's going to be B and C that's multiplied by -2. And then AC, AC, AB, AB. So they're all a little bit different, but they all follow the same pattern. All right, so let's look at a couple of triangles. It says, solve for the remaining sides of the triangle described below. Round to the nearest thousandth. So solve for the remaining sides. We're really just going to solve the whole triangle. So we'll just say solve the triangle. Solve the triangle described below. Remember, to solve a triangle means to find all of its angles and all of its sides. It says round to the nearest thousandth. How many decimal places is that? 2, 3, yeah. 3 decimal places. I'm going to try turning this lamp off and see if that helps. Yeah, that's better. All right, so first one we have angle C is 70 degrees, side B is 3, and side A is 2. All right, so you can either do one of 2 things first. You can go ahead and write out this little, I call it like a table. Or you could draw a picture. Either one is a fine way to start. So I just went ahead and drew out my little table. I'm going to fill in what I know. I know C is 70 degrees. Little b is 3. Little a is 2. This just helps you see like what you still have left to find and where you should start. So I'm going to sketch a little picture. You don't have to sketch a picture, but I think it helps. Just, of course, make it something that's not a right triangle. And then we'll fill in what we know. I'm just going to label this A, B, C. Let's see, C is 70. There's no, incorrect way to list A, B, and C. You could put B down here, A on the right-hand side, and C at the top. It doesn't matter. That wherever you draw the angles, that's going to tell you where your sides go. So if this is the angle A, straight across from here, that's going to be side A. So side A is 2. And then, let's see, we know little b is 3. So straight across from the angle B, we have side C is 3. Or excuse me, side B is 3. All right, so first thing you're going to do is just find that remaining side. we want to have at least one matching like angle inside. So you want to have at least one where you know the angle and the side. So we'll go ahead and find little c, and that's going to help us find a matching angle inside. Now, this is like a place where, I know it sounds silly right now, but sometimes people will think like, okay, well, I know two sides, I can use Pythagorean theorem to find the last side. Don't do that. You shouldn't have to use Pythagorean theorem at all on this test. So you have to use law of cosines, because this is a side angle side triangle. Right, so this is side angle side. Side angle side means, we go to our little table here. Side angle side means we use law of cosines. All right, so we're going to use the law of cosines. That involves the angle C, because that's the angle that we know. So that's this bottom version of the formula. It's the bottom version of the formula over there as well. All right, so let's write out the formula. We have C squared equals A squared plus B squared minus 2AB times cosine of C. You can leave the parentheses off of the angle. You can write the parentheses around the angle. It doesn't matter. Whatever notation you prefer. All right, so we have C squared. We don't know C. We don't know little c. So just keep that as C squared equals A squared plus B squared. That's 2 squared plus 3 squared minus 2AB. So that's minus 2 times 2 times 3 times cosine of big C is 70 degrees. All right, so if we're plugging this in the calculator, what mode should we be in? Degree mode. Good. So make sure you're in degree mode. One last thing before we type this in, I'm just going to save you a little bit of time in just a second. We need to get C by itself. So how do we get rid of squares? Square root. Good. So we're going to take the square root of both sides and then go ahead and type it in. That just saves you from having to do that at the end. So when you have a square, you can cancel it out by taking the square root. And we don't have to worry about doing plus or minus here, because this is representing sides of a triangle, which is sort of like a distance. The distance should always be positive. All right, so I'm going to plug this in my calculator, make sure I'm in degree mode, and I am. All right, so square root 2 squared plus 3 squared minus 2 times 2 times 3 times cosine of 70 degrees. And down to 3 decimal places, what would that be? 2.983. Good. So C is 2.983. 2.983. Just filling it in my little table up here. Now let me show you what it would look like if you forgot to take the square root. It's kind of it's not going to look like you did anything wrong if you forget to take the square root. So for example, say I just plugged it in as 2 squared plus 3 squared minus 2 times 3 times cosine of 70. That looks totally like a normal answer. So it doesn't give you any kind of like weird answer if you forget to take the square root. So you got to make sure and remember, okay, I got to get C by itself, so I have to get rid of this squared. I have to take the square root of both sides. So that is sort of one bad thing about this, is that there's not gonna be any red flags if you forget to take the square root. It just looks completely normal, and then that's gonna mess up everything else for you. All right, so like I said just a few minutes ago, one good thing about law of cosines is that you only ever have to use it once. Once you have found a matching side and angle, you can then use law of sines. So that's sort of like the qualification for using law of sines. You got to have a matching side with a matching angle. All right, so now that we have big C and little c, you can go ahead and use law of sines to find the next angle. Now, how do we know which angle to find next? My rule that I always go by is find the biggest angle first. All right, so add that up here on your notes. Find the biggest angle first. All right, so find the biggest angle first. That goes for any problem like law of cosines or law of sines. You should always start with finding your biggest angle. So let's see, our biggest side is side B, so that means our biggest angle will be angle B. So we're going to find angle B next. We're going to use law of sines. All right, so we're going to do little b over sine of big B equals little c over sine of big C. And remember, we talked about with law of sines how you can use this version of the formula, but if you do the reciprocal and do like sine of big B over little b equals sine of big C over little c, it's going to give you the same answer. So you can use either version of this formula. It's all about the fact that it's just the ratios are equal, so it doesn't matter if you put sine of big B in the numerator or in the denominator, as long as they match. So let's fill in what we know. Let's see, we know little b is 3. Little b is 3. We don't know big B equals little c is 2.983 over sine of big C is 70 degrees. All right, so then you got to decide, do I need to just multiply by the denominator, or is that not really going to help me that much? Should I just go ahead and cross multiply? What do y'all think? If I multiply by sine of B, does that get anything by itself? It gets 3 by itself, but it doesn't really help us that 3 is by itself. So you're just going to go ahead and cross multiply. The only time it really helps you just to multiply that by the denominator is if you have a variable in the numerator. So if your variable's in the numerator, multiply both sides by the denominator. Otherwise, just cross multiply. All right, so that's 3 times sine of 70 degrees equals sine of B times 2.983. I should have put the 2.983 in the front, but it's okay. Let me move this out of the way. All right, so trying to get B by itself, go ahead and divide by 2.983. Divide by 2.983. Cancels out over here. Then we have 3 times sine of 70 degrees over 2.983 equals sine of B. Now, how do we get rid of that sine? Good. Inverse sine, good. So we're going to take the inverse sine of both sides. Inverse sine of both sides. That's going to cancel out the sine over here. So inverse sine cancels out with sine. Those are inverses. And then we can just type that left-hand side into the calculator. Should still be in degree mode. You can give problems like with law of sines and law of cosines. You can give problems in terms of radians, but most of the time you're going to see them given in degree. All right, so let's type this in. Inverse sine 3 times sine of 70 over 2.983. Okay, 70 point, we rounded to 3 decimal places, so that's 917, 70.917. Did I get that? Yep, okay. 70.917, that's B. Finding the last angle is always easy. You don't have to use law of cosines or law of sines. You can just use the fact that all the angles have to add to 180. So just do 180 minus 70 minus 70.917. That's going to tell you your last angle. 39.083. One way you can check and see just that your answers make sense, there's no good way to check your answer on these, but one way you can check and see if your answers make sense is to say, okay, well, the biggest side needs to match with the biggest angle, and it does. And then the next biggest side needs to match with the next biggest angle, which it does. And then the smallest side should match with the smallest angle. All right, so that kind of just like helps you see, okay, do my answers match up? Do I have everything in the right place? Right, so this is your actual answer. Any questions about side angles, side triangles? So the process is use law of sines to find your missing side, and then you can, use law of cosines to find your missing side, and then you can use law of sines from there.
I have a question. So are we going to have to know the difference between law of sines and law of cosines?
I don't mind putting in the directions, like use law of cosines to solve the triangle. I don't mind doing that.
So generally, are we going to know C if you're using side and side?
If you know a matching side and a matching angle, you would automatically know I can use the law of sines. If you don't have a matching side and a matching angle, you would know, okay, I have to use law of cosines. Does that make sense? Yes. Yeah, like in this scenario, we only knew big C, we didn't know little c, so that would tell us, okay, we have to use law of cosines on this one. All right, the next one is side, side, side. These are the harder of the law of cosine problems. So side, 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 of course, where you know three sides, you don't know any angles. Here we have A is 7, B is 8, C is 5. Once you get this written down, go ahead and start writing out your little table and then fill in what you know. And then you can draw a picture. Yep. All right, so same thing here. You got to think, like, where do you start out? You're finding your biggest angle first. Which one of these is going to be the biggest angle, A, B, or C? B. Good. So we're going to find B first. We're going to use law of cosines because we don't have any matching sides and matching angles. I'm going to draw a little picture over here and label these. I always like to label the angles first, and then I can go from there as far as labeling the sides. So A is 7, little a is 7, little b is 8, and little c is 5. So you can see my picture is not accurate. The side 5 looks bigger than the side 7, but that's okay. This just gives you a way to visualize, what's across from what am I missing. All right, so find big B first because it's the biggest angle. Okay, so you go to law of cosines and write down the law of cosines for the angle big B, which is the middle one. So B squared equals A squared plus C squared minus 2AC times cosine of B. So here's our formula. Okay, then go ahead and just fill in what you know. Let's see. We know A, B, and C. So little b is 8. A is 7. C is 5. Isn't this so fun? Do you love this? I just think this seems fun. Maybe that makes me a psychopath. All right, so let me show you why this is a little bit more difficult than a side angle side triangle problem. All right, so we need to get B by itself. B is all up in the middle of this huge equation over here. So we're going to have to move things over piece by piece to try to get big B by itself. All right, so you're going to subtract over. You can go ahead and evaluate these. If you want to do this is 64, this is 49, this is 25, you can do that. You don't have to, though. That could cause you to just make a simple mistake. So I just leave them in there. So I go ahead and I subtract both of those over. cancel them out. All right, so then I have 8 squared minus 7 squared minus 5 squared equals -2 times 7 times 5 times cosine of b. Now, like I said, if you feel like this would look a lot easier if I just went ahead and solved this left-hand side or simplified this left-hand side, and then you could do -2 times 7 times 5, what would that be, like -70? You can do that as well. But I'm just showing you how I do it, and I always just leave them in there. We're really close to getting b by itself. We just need to divide by this coefficient. So divide by -2 times 7 times 5. So dividing by that coefficient. That cancels this out. All right, then we got this big fraction on the left. Equals cosine of b. And then we just did this a minute ago, but how do we get rid of cosine in this case? Inverse cosine of both sides. So inverse cosine of both sides is going to cancel out the cosine on the right-hand side. And then you can type this in. If you have either this TI-36 or if you have a TI-84, I would definitely suggest using that little fraction button to make this look a little bit neater. So if you're working with a TI-84, you could do inverse cosine, and then if you hit alpha, and then x, that's going to pull up a little fraction for you, alpha x. If you have TI-83, it doesn't have this function. But then you can type it in from here. It just looks a little bit neater. So 8 squared minus 7 squared minus 5 squared over -2 times 7 times 5. And there we go. We're going to round this to 3 decimal places again. So 81.787. Did y'all get that? Yeah? Okay. All right, let's fill that in our little table. All right, then you go ahead and you find the next biggest side, or excuse me, not next biggest side, next biggest angle. But you can use all of signs to do that now because we have a matching angle and a matching side. All right, so once you've got that matching angle inside, you can then use the off signs. Which one will we find next, A or C? A, good. That's the next biggest angle. So we can go down here and find A. And then we can use the off signs. So we'll do little a over sine of big A equals little b over sine of big B. I know I'm supposed to use little b over sine of big B because that's the one I know the matching side and angle. So I know little a is 7. I don't know the angle A. Little b is 8. Big B is 81.787. Okay. We're going to have to cross multiply here. It's not going to really help you to multiply by the denominator. So go ahead and cross multiply. This is just like that second step we did in the last problem. All right, remember to write my coefficient out front this time. I'm going to divide both sides by 8 to trying to get A by itself. Cancel that. And then to get A by itself, what do? Inverse sine. Good. All right, so I ran out of room, so I'm going up here. So A would be inverse sine of that left-hand side. Okay. Have y'all typed that in already? What'd y'all get? 60? Yeah. Yeah, when I first did this, I was like, that can't be right. You almost never come out with a perfect angle like that. But in this case, this is correct. All right, so go ahead back up to your table, fill that in, and then always remember last angle, super easy to find. You just take 180, subtract off those two angles that you know. So do I get 38.213? There we go. That's our answer. I'll usually just like write in this little table for you on the test, so you don't have to write like ABC every time. I'll just put this on there, and you'll fill in the entire table, and that'll be like your solution. All right, so we have 2 word problems, and then we have the Heron's formula, then we'll be done. All right, so I'm going to give you all a minute to write down this word problem. It's kind of long. This one says, a toy boat's floating down a river. Some of y'all's problems in the homework would say something like a kayak is floating down a river. The toy boat is first spotted 35 feet away. 7 minutes later, time doesn't matter. Just ignore the time. 7 minutes later, the boat is 10 feet away. It's making a 60-degree angle between the 2 sidings. How far did the toy boat travel? Round to the nearest tenth, so 1 decimal place. I don't really love the wording of this problem, but it's a good way to practice law of cosines, so I kept it on here. I just think the description is kind of not super clear of what this would look like in real life. So we got a toy boat floating down a river. So say you're standing on like the bank of the river, you see it, it's 35 feet away from you. A few minutes later you look again, and then it's 10 feet away from you now, making a 60-degree angle between the sidings. So it sort of drifted off to the side. How far did the toy boat travel? All right, so as y'all are writing that down, I'll go ahead and draw the picture. Let's see. Let's say that I'm here. Great picture. I don't know why I broke my back in this picture. And it's 35 feet away from me, so it's right here. Here's the boat. And then it turns a little bit, and then it floats 10 more feet. So that makes a 60-degree angle. And go ahead and fill in your numbers here. At first it was 35 feet away. It drifted 10 more feet. And how far did it travel? So go ahead and connect the last side of that triangle. This is your second siding down here. And so this is going to be the final distance it is from me. So this is what I'm looking for. We'll call this side D for distance. All right, so you just look at your triangle. At this point, once you've got your picture drawn, you can kind of ignore the scenario and just look at your triangle. We're in law of cosine, so is this a side angle side or side side side? Yep, side angle side. We know 2 sides and the angle between them. So that's side angle side. All right, so you can label this triangle. I probably should have labeled it first and then named that variable, because now I'm going to have to rename this. So this, if this is the angle B, this would be little b. Yeah, I should have waited to name that. That's my bad. All right, so remember how you figure out which version of the law of cosines that you're using. You look and see, okay, which angle do I know? I know the angle B, so I'm going to use the middle version of the formula. So b squared equals a squared plus c squared minus 2ac times cosine of b. So write your little formula down. Okay, then just fill in what you know. All right, so little a is 10, little c is 35. All right, so that's b squared equals 10 squared plus 35 squared minus 2 times 10 times 35 times cosine of 60 degrees. Do y'all remember what cosine of 60 degrees is from the unit circle? What? How dare you? I don't know what it is either. I think it's square root of 3 over 2, but I'm not sure. Is it 1/2? I don't know. Yeah, my bad. Alright, so remember we could type this in right now, but really it's going to help you out if you just go ahead and take the square root of both sides. So go ahead and take the square root of both sides. That's going to get b by itself, and then you don't have to worry about doing that at the end, which could make you accidentally forget. Alright, so let's type that in. Square root 10 squared plus 35 squared minus 2 times 10 times 35 times cosine of 60. Make sure you're in degree mode. 31.224, 225, I guess. Did I get that? 31.225. And sorry, we're supposed to round to 1 decimal place, so what would that be? Yep, just 31.2. And that's all you have to do. You don't have to solve the whole triangle. That's sort of the good thing about these word problems, is they typically just want one thing. So they usually just want one thing. You don't have to worry about solving the whole triangle, which is nice. But like I said, I definitely wanted to go through this one with you guys just so you could see how I set up my picture. And that should help you set yours up as well. All right, then we have this question about a bookshelf. So it's a little bit, I feel like it's a little bit longer. Says a homeowner makes a corner bookshelf for his photos and knickknacks in an inside corner of his den. The lengths of the sides of the corner bookshelf are 31 inches, 33 inches, and 23 inches. What are the respective angles in degrees? Round to the nearest hundredth. Yep, side, side, side. So think about it in terms of, like, imagine you're standing over the bookshelf and looking at it from above. It would, if this is the corner of the room, it would look like this. So this is like sort of the above view, the aerial view of your bookshelf. It's in the corner of the room over here. You can go ahead and label your sides. And then on this one, you do have to find all 3 angles. It asks what are the respective angles. So you need to find all 3. Doesn't matter how you label these sides. If you put them in different spots than me, then that's fine. I'm going to call this one A, this one B, and this one C. Just label them like the first one A, second one they named was B, third one they named was C. All right, that's going to help me label my angles. This would be A, this would be B, this would be C. All right, so side, side, side. So you definitely got to use law of cosines. All right, so we need to find the biggest angle first. Which would be the biggest angle, A, B, or C? B. B, good. So find B first. And you can draw it in a table if you like the way this looks better. I think it looks a little bit neater to draw the table. Alright, so find big B. We're going to use the law of cosines for big B. We just used it, so should be fresh on your mind. Fill in what you know. We know little b is 33, little a is 31, little c is 23. And this is the one where you have to do all that work at the beginning, side, side, side. It has that, the first step is really long. So you got to subtract over these guys in the front and then divide by the coefficient. So subtract over those two terms in the front that are being squared, and then you're going to divide by the coefficient. All right, so that's -2 times 31 times 23 times cosine of b. Go ahead and cancel these out. Divide by that coefficient. And then your last step is to do what? Yeah, inverse cosine on both sides. So these problems they're kind of long, but the good thing about them is that you do them the same way every time. So if you can remember that pattern, then you could write like a little example on your formula sheet or something like that, and have like a little pattern for you to follow. All right, so plugging this in my calculator, inverse cosine 33 squared minus 31 squared minus 23 squared. So I get 73, it says round to the nearest hundred, so 2 decimal places. 73.67. Yep, that's what I got earlier. 73.67 degrees. Don't forget the degrees on all your angles. You can use law of sines to find the next side or the next angle. So now you can use law of sines. Sorry if I went too fast there. I'll put that back up for a second if you need to see it. Now that you know a matching side and a matching angle, you can use law of sines. Our matching side and angle are B. And what's the next biggest angle? What do we need to find next? A. Yes. So find A next. Find A. So little a over sine of big A equals little b over sine of big B, because that's the one we know the matching side and angle of. And then from here, this is exactly what we did on number 1, part B. So that's sine of A, 33 over sine of 73.67. Cross multiply, and then take the inverse sine. So cross multiply, I forgot to say you got to divide by that 33 first. Once you've got sine by itself, then you take the inverse sine. To get A by itself. So take the inverse sine of that big fraction. And then from there, all the hard part's done. You can just subtract the angles from 180 to figure out the last one. I'm just talking inverse sine 31 times sine 73.67, 33. 64.4. Oh, no, I'm sorry. I keep forgetting how many decimal places we're using. We're using 2 here. So that'd be 64.36. Okay, so go back to the table, fill that one in. All right, and then subtract those from 180 to get your last angle. 41.97. And then, like I said a few minutes ago, you can make sure that your answer makes sense by making sure, like, okay, does the biggest side match with the biggest angle? Does the smallest side match with the smallest angle? Does that work out here? Smallest side, smallest angle, yeah, that works. Biggest side, biggest angle, yeah. So everything looks right. If something didn't match up properly, we would know that we did something wrong somewhere. All right, so that's all my examples for law of cosines. The last thing I have is just Heron's formula, which is pretty simple. So Heron's formula is super old formula. It is used to find the area of a triangle where you don't know any of the angles. Now, of course, you could like find the angles and then use the formula from the last section, but I think Heron's formula is actually a little bit easier. So this is only used when you have a side-side-side triangle. All right, so here's Heron's formula. Name for Heron of Alexandria. It's like one of the oldest known formulas that we have in this class. All right, so given a triangle with sides A, B, and C, let S, that represents what's called the semi-perimeter. It's like half of the perimeter. So let S be A plus B plus C, so add all the sides up, that would be the perimeter of the triangle, and then divide by 2. Then the area is equal to the square root of S times S minus A times S minus B times S minus C. I'm sure there's like a cool proof for this formula, but we won't go through it in this class. That's more of like a geometry, modern geometry topic. All right, so first example that I'm going to show you is just really straightforward. It just gives you the sides and you plug them into the formula. And then I have a word problem for you. All right, so we have number 4, just find the area of the triangle, round to the nearest hundredth. A is 16, B is 29, C is 17. You don't even need to draw a picture here. You can just plug this straight into the formula. First thing you need to find, though, is that semi-perimeter. So find S first every time. So go in, write down S is equal to A plus B plus C divided by 2. So 16 plus 29 plus 17 all over 2, which is how much? 31. All right, and then you can plug everything into your formula. You know everything you need to know at this point. So area equals big square root. We'll draw the top at the end. All right, so it's S, which is 31, times S minus A, times S minus B, times S minus C. Well, 31 minus 17. Right, draw the line over the top, the radical. And then just plug this in. Round into 3 decimal places. Did I do something wrong? I missed a parentheses right there. Oh, I missed 2 parentheses. Oh God, just to delete the whole thing. All right, 31 times 31 minus 16, 31 minus 29, 31. Okay, that's better. Try to get that. 3 decimal places, that'd be 114.105. No units were given, so we don't have to worry about units on this one.
Wouldn't it be the 1 because the nearest 100?
Yes, you're right. Good Lord. They might have something on there like units squared. Like at the end, they might say something like units squared. So remember, area is always whatever the units are, feet, inches, centimeters, whatever, squared. And then the last one is a word problem. Sorry, this is a lot of writing. Margaret wants to build a fenced-in area for the dog in the backyard, but it's only using the area beyond the path running through the yard. So at first I couldn't think, like, what does this mean? It's got to be a triangle. So just imagine, like, this is her yard, and she must have a path that's running, like, diagonally. And then this is going to be your fenced area. All right, so it says, how large would the fenced area be if it is triangular shaped with sides of length 13 feet, 8 feet, and 18 feet, round to the nearest hundredth? So again, you don't have to draw a picture on these area problems, but sometimes the pictures from help are not the best. So just in case you're wondering what that would look like. So how large would the fenced area be? So that's telling you to find the area. So this is a side triangle. So we're going to use Heron's formula. We need to find the semi-perimeter first. So do that first, and then you can plug everything into your formula once you've got the semi-perimeter. I think this one comes out to a decimal. That's okay. As long as it's, like a terminating decimal, like I think this one is 19.5, that's fine. If it was like something weird like 19.27853, I would just leave it as a fraction in that case. Bless you. So if it came out to some weird decimal, just leave it as a fraction. Otherwise, it's okay to write it as a terminating decimal. All right, so S, the semi-perimeter, 13 plus 8 plus 18 all over 2 is 19.5. And then we can just plug it into our area formula for a side triangle. So 19.5 times 19.5 minus 13 times 19.5 minus 8 times 19.5 minus 18. All right, and then what do y'all get to 3 decimal places? Yep. And this one is in feet, 13 feet, 8 feet, 8 feet. So we'll do feet squared or square feet. That's the fenced in area. So this could help this person determine how much fence they need to buy or whatever. All right, so let me stop this recording and talk about the test real quick.